Rational root theorem to factor polynomials. Not all polynomials are factorable. However, the rational root theorem can help you find all possible rational roots of a polynomial equation. The rational root theorem states that if the polynomial has an integer coefficient, then all rational roots can be written in the form of p over q. Now we need to know what p and q are in order for this to work. P is a factor of the constant term. And q is a factor of the leading coefficient. In this first example, we want to solve completely using the rational root theorem. Okay, so the first thing we want to do is actually find our possible rational roots. So we need our factors of 8, and those are our p's, and our factors of 1, and those are our q's. And then we take p divided by q. So that would be positive or negative 1, positive or negative 2, positive or negative 4, and positive or negative 8. And our possible rational numbers, possible factors for 1 is positive or negative 1. So that means we can have plus or minus 1 as a possible root, plus or minus 2 as a possible root, plus or minus 4, and plus or minus 8 as possible roots. So then we can apply the remainder theorem or the factor theorem, they're both the same thing, and then test out all of those. So if we do that, if we pick and we say f of 1, and we see if that is a factor. So then we put in 1 cubed plus 6 times 1 squared plus 12 times 1 plus 8 equals, and then if it equals 0, then that is a factor. That equals 31, so that means the factor x minus 1 is not a factor. So let's try a different one. Let's try negative 1 in the box. Okay, so if we put in negative 1 for x, negative 1 cubed plus 6 times negative 1 squared plus 12 times negative 1 plus 8 equals 1. So that means x plus 1 is not a factor. So let's try 2. 2 cubed plus 6 times 2 squared plus 12 times 2 plus 8, and that equals 64. So that means that x minus 2 is not a factor. So let's try another one. F of negative 2 equals negative 2 cubed plus 6 times negative 2 squared plus 12 times negative 2 plus 8. And if you type that in, then you get 0. So what that tells us is that the factor x plus 2 is a factor. Now that we've figured out a factor, we can use synthetic division in order to actually factor that out. So we know that x plus 2 is a factor of x cubed plus 6x plus 12x plus 8. So now we can actually figure out what that factor is by putting negative 2 in the box, and then we line it up with the coefficients 1, 6, 12, 8, making sure that we put in any placeholder zeros, which we don't have any this time. Add down. 1 times negative 2 is negative 2. Add down. 4 times negative 2 is negative 8. Add down. 4 times negative 2 is negative 8. Add down is 0. So that means when we have it factored out, we have the factor x plus 2 times x squared plus 4x plus 4. And then we can continue doing more synthetic division, or at this stage, we can pretty easily just factor out the way we've done before, factoring out quadratics. So we'd have x and x. Second sign is positive, so they're both the same, both going to be positive. Plus and plus. Multiply together to get 4. Add together to get 4. So that would be 2 and 2. Okay, and then it says to actually solve. So then I set it equal to 0. So I set each one equal to 0. And since they're all the same, I only actually have to do it one time. So I have x plus 2 equals 0. So I subtract the 2. And x equals negative 2. So my answer, my solution to this polynomial is x equals negative 2. And that is it. All right, for this next example, we want to solve using the rational root theorem. So we've got to find our factors of p and our factors of q and divide them. So my factors of p is positive or negative 27, positive or negative 9, positive or negative 3, positive or negative 1. And the factors of 1 is positive or negative 1. So that means that our possible rational roots are plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27. Okay, so now we have to try those out and find one that works. And then we can use synthetic division. So if we take f of 1, then that would be 1 to the 4th plus 8 times 1 cubed plus 18 times 1 squared minus 27. So that equals 0. And so that means that x minus 1 is a factor. So if we continue on with that and we use that as a factor, then we would put 1 in the box and then we line them up. 1, 8, 18. And then I have to put a placeholder 0 in, minus 27. Add down. 1 times 1 is 1. Add down. 9 times 1 is 9. Add down. 27 times 1 is 27. Add down. 27 times 1 is 27. Add down 0. So that means I have the factor x minus 1 and x cubed plus 9x squared plus 27x plus 27. So again, now I'm going to have to do the same thing because I can't just easily factor that one out. So I want to do a little bit more work. So the more work that I'm going to do is I'm going to go back and I'm going to find another factor. So I'm going to try putting negative 1 in the box. So if I do that, then I would have negative 1 to the 4th plus 8 times negative 1 cubed plus 18 times negative 1 squared minus 27 equals a negative 16. So that means that x plus 1 is not a factor. So then I try another one. Let's try f of 3. So 3, 4 plus 8 times 3 to the 3rd plus 18 times 3 squared minus 27 equals 432. So that means x minus 3 is not a factor. So now I got to try a few more. So we know now that x minus 1 is a factor of x to the 4th plus 8x cubed plus 18x squared minus 27. And when we did synthetic division, we found that we could factor that out to x minus 1 times x cubed plus 9x squared plus 27x plus 27. So now what we have to do is find another factor. So that's what we're working on right now. So let's try f of negative 3. So when we try f of negative 3, we get negative 3 to the 4th plus 8 times negative 3 cubed plus 18 times negative 3 squared minus 27. And we get 0 when we do that. So what that means is that x plus 3 is a factor. So now we do synthetic division again, and we're going to put negative 3 in the box. So that means that we have negative 3, and this time I'm going to go ahead and use this factor right here. 1, 9, 27, 27. Since we already know that we factored out the x minus 1, I can just use that. So then I add down, 1 times negative 3 is negative 3, add down, 6 times negative 3 is negative 18, add down, 9 times negative 3 is negative 27, add down is 0. So now what I have is I have x minus 1, x plus 3, x squared plus 6x plus 9. And now it's easy enough to factor out using previous knowledge of factoring quadratics. X and x, second sign is positive, both going to be the first sign, which is positive, plus, plus. They need to add together to get, multiply together to get 9, add together to get 6. So that would be 3 and 3. So now I need to just set everything equal to 0. So I technically only have to do 2. I have to set x minus 1 equal to 0 and x plus 3 equal to 0. I only have to do those two because there are just 3 x plus 3's. So when I solve, that's going to give me x equals positive 1 and x equals negative 3. Therefore, my solution is x equals 1 or x equals negative 3. And those are your answers. So we have used both the rational root theorem and the factor or remainder theorem to solve these. Those are your notes over the rational root theorem to factor polynomials. Go through the practice problems, get comfortable with using the rational root theorem and synthetic division, and then you can take your quiz over this material.